Okay, Longhorns, I need you to turn to page 259 in your notebook, and we're going to take a few notes down about the tangent function and graphing the tangent function. And then in class, we're going to actually practice some graphing of the tangent function, but I would like for you to first get a little background knowledge about it before we actually start graphing in class. The first thing I'm going to do is I'm going to go ahead and draw a sketch of a unit circle. You can look at your unit circle as I go through this, but I'm going to draw a sketch of a unit circle, and I'm going to talk a little bit about the values of tangent before we actually fill in this grid that's here at the top of your notes. Okay, so I'm going to take a break here for a minute and do that. Hold on. Okay, so here's a rough sketch of our unit circle. And as you know, this point here is the point 1, 0. And this point up here is 0, 1. And then the one over here on the left is negative 1, 0. And then the one at the bottom is 0, negative 1. And these angle measurements are 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so let's talk real quick about what each one of these coordinates values mean. And I'm just reviewing real quick. The x values are the cosine values, and the y values are the sine values. So if you remember when we did the tangent values all the way around the unit circle, we said that the sine value of theta divided by cosine was tangent. So we went around the unit circle and we identified all of our tangent values. There are some places on the unit circle, if you recall, and it's probably written on your circle, where tangent is undefined. And those two spots are there at the top at pi over 2, tangent is undefined. And then at 3 pi over 2, tangent is undefined. So as we're graphing tangent, you're going to see that tangent actually repeats at every pi cycle between pi over 2 and 3 pi. Because at pi over 2 and 3 pi, tangent is undefined. And we're going to have an asymptote right there. So let's go ahead and fill in our chart. Okay, so the period for tangent graph is going to be pi instead of 2 pi. So since we can only go halfway around the circle before we are undefined for tangent, then now our period for tangent is going to be pi. So we're going to graph our graph at 0, pi over 4, pi over 2, 3 pi over 4, and pi. All right, so what we need to do now is we need to identify what all of our sine and cosine values are at those angle measures. So we're going to look at sine first. So y we're going to call our sine of theta. And sine of theta at 0 is 0. At pi over 4, it's root 2 over 2. At pi over 2 is 1. At 3 pi over 4 is root 2 over 2. And at pi is 0 again. And then our cosine of theta is going to be 1. And then at pi over 4 is again root 2 over 2. And at pi over 2 is 0. And then root 2 over 2. And again 1 at, or negative 1 at pi. All right, so where the word says graph, we're going to put the tangent of theta. And so you should have on your unit circle all of the tangents. identified, but we're going to go ahead and write them down in this box anyway. So our first tangent of theta is sine over cosine, 0 over 1, or 0. Our next tangent at pi over 4 is root 2 over 2 divided by root 2 over 2, which is just 1. Then we have pi over 2. Now this is where we have an interesting place in our graph. It's called our asymptote. And because sine over cosine is 1 over 0, and we can't divide by 0. So tangent at that angle is undefined, or it's a vertical line. 3 pi over 4, again, we have root 2 over 2 and negative root 2 over 2. And here we're going to have a negative 1. And the last one at pi is 0 over negative 1, or we can just say 0. So our tangent values are going to be 0, 1, undefined, negative 1, and then 0 as we graph the tangent graph. So in your notes here you have already a tangent graph, the parent function, graphed for you. And you have over here on the side a little mini unit circle. And the y-axis right here, where pi over 2 and 3 pi over 2 are, those two values for tangent are undefined. I've expanded the graph a little bit so that you can see a little bit better where exactly we're graphing tangent and where the asymptotes exist. So first of all, if we graph our first point, 0, 0, that point's right here at the origin. The next point we're going to graph is pi over 4, 1. Then we have undefined. That's this line right here, this vertical line that goes through, and it's our asymptote. Then the graph repeats. It repeats when we get to 3 pi over 4, negative 1, and then back at pi, 0. And as you can see, this graph comes up through the intercept and back up again along the asymptotes. Back down, it repeats, comes back up through the other side along the other asymptote. Okay, so let's take a look at the chart at the bottom underneath the graph. Here we're going to just enter some information about tangent. That's important. The intercepts of tangent are going to be 0 plus or minus pi n. And since we start at 0, and since we start at 0 with the parent function, then every pi, which was our period, we're going to have another intercept. So at every pi, there's another intercept. So we say 0 plus or minus pi n, comma 0 for our intercepts for tangent. The domain is written all real numbers except where pi over 2 plus or minus pi n occurs, because this is where the asymptote occurs. So you need to write this down, pi over 2 plus or minus pi n. There's an asymptote at pi over 2, and then every period distance before and after that, there's going to be another asymptote. So tangent has an asymptote every period pi after and before pi over 2. The range is all real numbers. So negative infinity to positive infinity is going to be the range for tangent. The amplitude for tangent is undefined. We don't have an amplitude. See, range is negative infinity to positive infinity, so there's no maximum and there's no minimum, so we don't have any amplitude. After sketching the x-intercepts and a few points, you can complete one period. We're going to practice this tomorrow in class, so you're going to get to actually do some hands-on graphing of tangent. And the last statement here, why is pi so important? You have to remember, this is the period and the distance between two consecutive asymptotes for tangent. So remember, the period for sine and cosine was 2 pi, but the period for tangent is pi. It can only go halfway around the circle before it has to repeat.